Here is the answer for day 4. Amoxicillin is an antibiotic often used to treat respiratory infections. Identify at least 4 functional groups in an amoxicillin molecule. Well, 3 places that jump out at me right away are the 3 spots where I see carbonyl groups. Here is a carbon atom double bonded to an oxygen. Let's take a look at what this carbon is bonded to. In this direction, it's bonded to another carbon. That is the rest of the molecule. In this direction, it's bonded to a nitrogen. This structure right here is called an amide. Now let's go to the next place where there's a carbonyl. This carbon is double bonded to the oxygen, the carbonyl. Now let's take a look at what this carbon is bonded to. Going in this direction, it's bonded to a carbon, so that is the rest of the molecule. Going in this direction, it's bonded to a nitrogen. So like the last one, this is an amide. Now down in the bottom right corner, there's another instance of a carbonyl. The carbon is double bonded to the oxygen. Going in this direction, it's bonded to another carbon. But going in this direction, it's bonded to an OH. This structure is called a carboxylic acid. Now, using the posters on the wall, that might be all that you can find. But there's some other spots that might catch your attention. For example, we see the benzene ring. Connected to that benzene ring, there's an OH. This structure, I don't have a poster for it, but it's called phenol. Now another spot that might catch your attention is over here. The sulfur atom, going in this direction, is connected to a carbon, and going in this direction is connected to a carbon. That structure is a thioether. Recall that an ether is when you have an oxygen connected to the rest of the molecule on both sides. This is sort of like that, but in place of the oxygen, there is an S, a sulfur. So instead of ether, it is thioether.